spectacle of a volcano in action was regarded with superstitious awe for many centuries. Today, we realize that even such demons of destruction are merely manifestations of great natural forces within the Earth's crust. This crust is relatively thin. Beneath it, the hot interior has a density much greater than that of surface rocks. Due to the tremendous pressure from above, most of this interior is regarded as solid in spite of its great heat. But when the pressure on an area near the surface is reduced by any great crustal movement, large quantities of the inner rock melt and form a liquid called magma. This hot magma may solidify before reaching the surface and form a great mass known as a batholith. If later the overlying strata are eroded away, rugged mountains such as these may be carved out of the exposed granite batholiths. Or the hot magma may cut across existing rock strata, cooling and hardening there to form another type of igneous rock. Such formations, called dikes, may later be laid bare by erosion. Commonly, they are found standing as irregular walls above the adjacent and less resistant rock. The hot magma may also force its way in between rock strata and, raising the overlying beds, may spread out over a wide area. The resulting formation is called a sill. The dark band along this mountain face is the edge of a sill 75 feet thick. This once molten rock is responsible for the baked zone in the adjacent strata. In some sills, the magma, on cooling, has formed columnar joints. Occasionally, the molten magma arches the overlying strata and takes the shape of a dome called a laccolith. Erosion has laid bare such a formation here in Eldon Mountain, Arizona. This eroded laccolith is about 3 miles in diameter. When hot magma intrudes into limestone, the baking effect of the great heat may change the fine-grained limestone into coarse-grained marble. If the magma contains compounds of lead, zinc, silver, or other metals, their ores may be deposited in the limestone. Such ores are commonly mined by sinking shafts into these ancient igneous contact zones. Magma or lava, on cooling at some depth beneath the surface, may become granite. If the cooling is relatively rapid, the rock is fine-grained. But if the cooling is very slow, a coarse-grained granite results. Instead of solidifying at great depth, magma may work its way toward the surface. Here, if the molten rock contains enough highly compressed gases, a violent explosion results. Steam and other gases burst from the crater with tremendous force. Solid fragments of hardened lava, varying in size from fine dust to huge blocks, are thrown upward to great height and scattered far and wide. Or molten lava may issue from the crater and spread out over the surrounding land. As this lava creeps slowly forward over the countryside, it may bury fertile fields and destroy buildings and even entire cities. It is this lava and solid debris that build up volcanic cones. Commonly, the cone is built of alternate layers of lava and ash. Lava causes the cone to widen out. Solid debris causes the cone to build up steeply. A nearly perfect example of such a composite cone is Mayon volcano in the Philippines. Within our own country, lofty Mount Shasta, now a dormant volcano, also belongs to this type. Occasionally, cones resulting from explosive eruptions may be built almost entirely of volcanic ash. The larger fragments fall nearest the vent, but the smaller particles are thrown farther out on the flanks. This small cone in Arizona, known as Sunset Crater, shows the characteristic steep cinder cone slope. A remarkable example of such a cinder cone is Wizard Island, which rises out of Crater Lake, Oregon. This lake occupies the crater of a much larger and older volcano. It measures about 5 miles in diameter and offers a clue as to the great size of the old cone. The top of the old volcano, shown here in reconstruction, is gone, either because it collapsed or was blown to bits, or because it was destroyed by a combination of these two phenomena. Then a new eruption built a cinder cone within this huge basin or caldera. Rain and snow filled the basin with water. Thus was formed the present Crater Lake, with Wizard Island rising above it. We have now seen how cones are formed by composite products or by cinders alone. A cone may also be built up almost wholly of lava. If the lava is somewhat thick and viscous, there will be a fairly pronounced slope, although not nearly so steep as those formed from cinders. This is the peak of Mauna Loa, a lava cone, which makes up most of the island of Hawaii. It has built up its great pile of lava 30,000 feet above the Pacific's floor. On the slope of this great cone and 4,000 feet below its summit is located Kilauea, with its almost constantly active pit of Halamomo. Lava in an extremely liquid condition flows like heavy oil and thus may spread out over a very wide area. Instead of issuing from a single hole, lava may flow out of a long fissure. In the geologic past, molten rock flowing through such fissures buried large portions of the states of Washington, Oregon, and Idaho with thick sheets of lava. The two distinct major flows, separated here in animation, are easily discernible in the field. Just south of this area is Lassen Peak, California, the only active volcano within the boundaries of the United States. Last in eruption in 1914, its present activity is confined to mud geysers and fumaroles. But as shown on this map, there are many recently extinct volcanoes, especially in our northwestern states. The world's active volcanoes lie in regions of recent mountain building. Thus, we find several hundred active vents forming a veritable ring of fire around the unstable margins of the Pacific. In the Dutch East Indies, which are a part of this ring, lies the volcanic island of Krakatoa. It was the scene of one of the greatest eruptions that man has known. In 1880, the island looked like this. On the 27th of August, 1883, there occurred 3 violent explosions. The last of these virtually blew the island to pieces. Merely a broken shell remained. The dotted line shows the outline of the island before the explosion. This and other violent volcanic eruptions, almost constantly occurring somewhere in the world, are spectacular evidence that our apparently stable Earth is in reality dynamic and ever-changing.